So, what does that tell us? How is that relevant for fixed lines? So this allows us to figure out all the fixed lines of Gaulight reflection. So assume L is fixed, line L, that Gaulight reflection moves into itself. Can it do it? Can it do so pointwise? Of course not. No points are fixed, but it conceivably may move the line into itself. So then, what can we say about such a line? For one thing, it cannot stay completely in one of the half planes, correct? Why not? Because then it would move into another half plane, will have no points in common with the original. So it definitely must intersect the axis of the Gaulight reflection. So we must have L intersect C. So let's call this point, say, L small, L capital. And let's see what happens to this point. So maybe at this point it's now is the good time for you to try and figure out the rest of the argument. So can you figure out all the lines that are fixed by Gaulight reflection? So stop, think about it, maybe go look at the book for a hint if you are stuck, and after that come back and let's continue with this argument. So we must have for a fixed line to have some point of intersection with the axis of the Gaulight reflection. And let's see what happens to this point. So where do you think gamma L goes? So let's call it L prime. We know that L prime must be distinct from L. What else do we know about L prime? Since the line is fixed, so original is on the line, and the line is fixed, we must have L prime also belong to the line, to the fixed line. Okay, so that means that the fixed line L is defined by L prime, since these are two distinct points on the line, right? A line is defined by two distinct points. We know the points are distinct, so we have L is L prime. On the other hand, we already noted that L belongs, the point L belongs to C, to the axis, and if you think about it, if we start with the point on the axis, then the image L prime of the point on the axis under Gaulight reflection must also belong to C. Why is that? Think about it. So then we also have two distinct points on the C. So I remind you, L was part of C by definition. So both of them belong to C. The axis of the Gaulight reflection, they are distinct. Hence, L prime is also equal to C. So we have from these two facts, we have that right, L must equal to C. So axis of reflection is the only line that is fixed by the Gaulight reflection. So let's summarize all of that into a theorem. So the Gaulight reflection fixes no points and interchanges the half planes of its axis. And interchanges the half planes of its axis C. Every point P and its image P prime have the midpoint on C, on the axis of glide reflection, and finally glide reflection fixes a line if and only if this line is the axis of the glide reflection. So glide reflection fixes its own axis and nothing else, and no other line. All right. So let's now talk in a bit more detail about the ways that we can write and rewrite glide reflection. So we said that glide reflection by definition is the product of two reflections in parallel lines followed by a reflection in a line that's perpendicular to both of them. So here we have 90-degree angles, two lines have a common perpendicular, which is the axis of glide reflection. How can we move things around here? So first of all, notice that we can rewrite sigma C, sigma B as what? As the half turn. This is the same as the half turn around the intersection, let's call it B. And that also means that we can rewrite it as sigma B sigma C. The reflections in perpendicular lines commute, right? The half turn can be written in any order whatsoever as long as the two lines are perpendicular. As long as we have a half turn, we can write any line first, any other line second, because it doesn't matter from which line we count the directed angle. 90 degrees is same as minus 90 degrees if we multiply it by 2. We get 180 or minus 180, the same thing. The difference is 360. So that's why we can commute the two, and then we can also notice that sigma C, sigma A can be written as a half turn around the point A, which is the intersection of A and C. So then we can write it as, well, then we can write it in a different order as well. So I'm saying that this part is sigma A, but then it means that the order is irrelevant here as well, and we can switch A and C. And finally, how about sigma A, sigma B, sigma C? Right? Wrong. Of course, why not? We can't write it like that, because if we could, then we would be commuting the two parallel lines, and we know sigma A followed by sigma B is a translation twice the directed distance in this direction, but this is a completely different one in the opposite direction, so of course not. So the upshot of these two is that our gamma glide reflection